Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction industry. Today also, I'm going to discuss about a very important topics, that is what is the comparison in between conventional concrete and the self-compacting concrete. Nowadays, self-compacting concrete is widely used in place of conventional concrete, but why self-compacting concrete is now widely used, and what is the comparison? What is the difference? In this video, I will discuss each and everything about this. So stay tuned until the end to get the full information about the comparison in between self-compacting concrete and conventional concrete. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's jump into the subject about the self-compacting concrete and conventional concrete. Now, if you want to know what is self-compacting concrete, what is ice code, and what is the properties, I have made a detailed video. Your link is there or in the description. You will check, you will get the full information about the self-compacting concrete. But today is the comparison. The first comparison is the workability. This self-compacting concrete or SCC is the high workability, flows and compact under its own weight without the need for vibration. So it is flowing under its own weight and vibrating itself. So there is no need for worker, no need for manpower for the vibration. But on the other hand, the conventional concrete requires mechanical vibration for compaction to eliminate air voids to ensure density. Now, here, if we are not using vibration or the mechanical vibrator in the conventional concrete, the air gaps will be there and will not get the compacted concretes, then the strength and durability will be concerned. But in the self-compacting concrete, it is not required any vibration because it's vibrating or under its own weight. So from the part of workability, from the strength, durability, it is a choice for the uh, ideal choice for the construction. But flowability, that is also required because self-compacting concrete is flow under its own weight to void all the corner of the formwork. So it is to be designed how it can easily flow. But on the other hand, the conventional concrete depends on mixed design, often requires additional work to fill formwork. So it is required to fill the every corner of the by manually or the mechanically for the conventional concrete. But in the self concrete, it is not required. So not required any worker, not required extra labor for the vibration, not required the extra effort to ensure that every corner is filled with the concrete. So that is its segregation resistance. Though the segregation is a really an issue for the concrete. And what is segregation? Segregation is the separation of its constitution from the concrete. So that can be two types of separation. One is segregation, that is separation of the coarser particle, that's aggregate from the mix, is called the segregation, and separation from of the water or the cement slurry from the mix is called the bleeding. So what is segregation, what is bleeding, and what is the impact on concrete and how to minimize that one? I have made a detailed video. Link is there or in the description. Please check. You will get full information about the segregation and the bleeding. For the segregation of the self-compacting concrete, it is designed to resist segregation. So there is a very minimum chance to segregate its aggregates and maintain uniform consistency. But in the conventional, it's prone to segregation if not properly designed, especially it hires some slum values. So it is to be specially designed and it is to be specially poured, transport, and everything to be taken care very precisely. Then bleeding, already we discussed that less bleeding due to the use of additives and finer materials such as fly ash and fillers, because the another criteria of this water powder ratio we have to maintain in the self-compacting concrete, which is resist the bleeding itself. But in the conventional, it's more prone to bleeding, especially at high water control cement ratios. Then vibration do not require, I already discussed, it's a vibrator under its own weight, but in the conventional, it's required mechanical vibration to ensure the compaction and proper fillings of voids. If it is not done as per the requirement, then there will be a void, there will be a honeycomb, and anything can be obviously that the strength and durability will be a concern. So what is compaction of concrete and how to do that one? What is the IS code and what is the method to do the compaction, I have made a detailed video on this. Please link it there or in the description. Please check. You will get full information about the compaction or the consolidation of concrete using mechanical vibrator. Then cohesion, high cohesion, reducing the risk of segregation and honeycombing. So it's the cohesive properties is there. Again, it's the honeycombing not will not form and the segregation will not happen. But cohesion depends on mixed proportion, higher chances of segregation if not properly mixed. Then surface finish. It provides a smoother and higher quality surface finish due to its self-compacting properties. So it has its own properties to compact and consolidate. But in the other hand, the conventional concrete, it doesn't have. It has to vibrate mechanically to make the finish as per the requirement. If the vibration is not proper, then the surface will not come as per the requirement. Then the labor requirement, low labor requirement equipment, since is the no compaction is required, so the vibration part is not there, and special care is not required because it is self-weight, it will flow and it will vibrate under its own weight. So, but in the conventional concrete, you need to vibrate and you need to ensure the vibration has taken place in every corner. There is a formwork pressure. It is a higher pressure in self-compacting concrete. That is why you need to design the formwork as per the pressure generated. That leads to specialized worker and leads to increase the cost. But in the formwork pressure, on the other hand, for the conventional concrete, it's a less pressure to former compared to SSC. So the conventional method we can use. And the mixed design complexity, it's a more complex design in the mixed design because you need to confirm the flowability, you need to confirm the cohesiveness, you need to confirm the viscosity, you need to confirm the segregation ratio. That are the complex things. What is the water cement ratio, then water powder ratio, then segregation ratio, that everything to be taken care while we are doing the mixed design for the self compacting. So it is more complex, and the use of admixture also, whether it is super plasticizer or viscosity modifying admixture, that is a more complex process. But on the other hand, in conventional method, it is not that much of kind of complex compared to the mixed self compacting concrete. It's simply a mixed design. And if you want to know how to do mixed design of a concrete, I have made a detailed video on this. Link is there or in the description. Please check. You will get full information about how to do the mixed design for self-compacting concrete as well as the normal concrete. Then it's a cost, higher initial cost due to use of admixture and precise in mixed design, and also the cement particles is because the finer particle is required more because to maintain the water powder ratio. That is a cement particle is more, cement content is more. That is why also the admixture and the VMA admixture is using. That is why the in cost is more, generally lower cost due to simpler material and mixed design in compared to SCC. And the durability, high durability, better resistance to segregation, honeycombing, and voids, ensuring longer service life. On the other hand, the conventional concrete durability can vary depending on compaction quality, risk of voids if not properly compacted. So it is totally in a manual, and it has to be closely follow up to maintain the durability. But on the other hand, the SCC, it's completely honeycombing and segregation and void is not there. Then construction speed is really it faster the construction speed. So whenever we are using the self-compacting concrete, because it's not required that much of manpower and that not that much vibration and that time. On the other hand, the conventional concrete is required more manpower and the time. And suitability for congested reinforcement, it is not to discuss because I have already discussed so many times that self-compacting concrete is ideal for the congested place due to its flowability all around the without obstruction. But if we want to use the conventional concrete in the confined space or the congested area, it is very much difficult to reach every corner of the formwork and do the proper compaction. So if it is a congested reinforcement area or the confined space area, the self-compacting concrete is the ideal choice. So these are the things about the self-compacting concrete and the comparison in between conventional concrete. But you need to choose as per your requirement. What is your project requirement? What is your project cost requirement? So on that basis, you need to choose where to use the conventional concrete and where to use the self-compacting concrete, because both has the requirement in the our projects. But according to the requirement, we need to choose what kind of concrete to be used in the project. So I think this is all, and I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comments, so that from your comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.